Hey everyone, this is Krish Patel from Team Decryptors. So in this video I'm going to talk about the prototypes and the model working of our problem statement, which is, you can see, centralized automated solution for price estimation and reasonability, right? So what we are going to discuss in this video is that how we are going to implement this idea and how our solution will help this problem statement and will be a good product for a government as well as normal user also, right? uh, we are not going to discuss the proper model, but from the prototypes and from the temporary data we can understand the flow, right? So let's go through it. uh, so let me show you. Our first thing that we are going to do is, yeah, you can see that user will give the input, and from the web crawling we will gather some real-time data. So if you don't know what web crawling is, here we are using beautiful soap library from Python. So what it does, it it pulls the data from HTML or XML files, and we can parse that data, and from that data we can predict other information, right? So this is how we will do web scraping. For example, a website like Amazon is there, right? Flipkart is there. There are some description, the product details, reviews, and all other things are present. So what we can do, we can scrap that data, and from that data we can predict related to our input and match that input with the scrap data and give other remaining informations, right? So let's go through it. Currently I'm not having the proper data set, so we are using the testing web scraper. There is a test site which matches our requirement. So for example, here is the site which has the information about computers and laptops. Now you can see some products here and with price and some descriptions are there, right? So how we are going to do web scraping here, let's go through it, some prototype. So as I've discussed, I've used some library like beautiful soap is there, and fuzzy wuzzy for fuzzy matching. uh, as you can see, there is a user query where product name is laptop, type is electronic, and currently, for example, I am exactly matching this description, so I have exactly written that, and I've given the web scraper website link. So what we are doing, we are extracting the product details, and if the product details fuzzy score is greater than our fuzzy threshold, here it is 70, then it will give the information. For example, I want to know the price of this product. What could be the price? So let's run this and understand this. Yes, you can see in the output, you can see the price rating, right? And also the fuzzy match score is 100 currently. So from that we can estimate the price and do my benchmarking, right? For example, I don't give the actual the exact information. What if I change some information? Let's say for example, instead of 500 GB I write 200 GB, right? And instead of 15.6 I write 14.6. What if it will give me the data? Yes, it will, because our threshold is greater than 70, and here fuzzy match score is 89, so it will give. But what if I change the whole data which is not present in my web scraping data? Let's say 13.6 displays there, and instead of AMD I give Intel i5 processor, and instead of 4 GB I give 8 GB, and 200 GB I give 1 TB, right? And Windows 8 instead I give Windows 11. Let's see how it works. Yes, still it is giving, because fuzzy match score is greater than 70, right? So let's do some more modification. What we can do, let's change the screen to 11.6 inches. Okay, still it is giving me So you know that's how it works. Let's make some more changes. Yeah, now you can see we are not getting the output because uh, fuzzy max score is not greater than the threshold value. So I hope you understand how web scraping is going to happen in this scenario. There are many websites from that we can extract the data. Biggest example is Amazon itself. Lots of products are there, and lots of categories are there, right? So we can utilize that data and get the information about the price estimation. So yeah, this is what about web scraping. Okay, so moving further in the process, now data normalization and structuring comes in the picture. So why we want to normalize the data? First we need to understand, you know, because uh, there could be the possibility that the data is not in the correct form. The data that we require is not present, and we want to do apply some algorithms on that. So for that, data should be in the structured way, right? It might happen that one thing that we are looking for example vintage, is not present in our scrapped data. Then what we can do, we can set any other parameter for that, or predict the parameter from the others matching nearest neighbors. We can also do that. No, k nearest neighbor concept comes here. That kind of thing we can do. So data normalization and structuring, let's understand from the example. Let's go through the same example. What I am doing here is putting the scrap data into a pandas dataset. Let's run this. Yes, now you can see the data is in the proper format: name, price, description, reviews, in the table format. So from the table format we can retrieve the data faster and modify, and any other operation can be done faster way, right? That is all the use case. Plus, for example, I want to do some normalization on the price. For example, let's say, from US dollar I want to convert it to INR, because for example I am scraping the data from Amazon US website, Amazon UK website, because there might possibility data might be available at that part but not in India. So we will scrap data from that websites. So we need to do normalize on the price for example US dollar to Indian rupees. So we will do in that part. Let's say for example here I have removed the dollar, right? You can see. So that part can be done. For trimming there is nothing to trim here, because as I have said, this is just a prototype, right? And also the parameters are very less in this example, because it will make much complex if parameters are higher in this, and it will be harder to visualize that part. For example, uh, purchase power of parity, that can be one parameter. What it is, the for example I am checking the price of any particular product in the US. So we cannot predict the same price for India also, because purchase power parity are different for both countries. Like anything, for example, one thing is 100 rupees in India, it could be possible that that is of $3 $4 in US, because the price ratio are high at that country, right? So we cannot directly scrap the data and put that in the data set. We need to do some normalization on that. We need to predict that regarding the purchase power parity, right? That could be one parameter. Like that, there will be different parameters, right? So this is the thing that will be done in the data normalization and structuring part, right? And from that we will move further to the next step. So I guess I hope you understand why this step is required from the given prototype, right? Okay, so now after data normalization structuring, machine learning pipelines comes in the picture. So the first thing that comes in mind is supervised learning, because there is input, and from that input there is a output y. From x the output is y, you know. Let's understand regression. Multiple regression algorithms are there, like linear regression, ridge regression, lasso regression, random forest regression. Multiple types of algorithms are there in regression only. Here I have selected random forest regression is because it might possible that after even structuring the data, there is no linear data relation possible, right? Like we cannot predict that data will be linear like this only, right? Points can be anywhere. So that is one choice of selecting this algorithm. Plus it handles the unfiltered data also, right? And also, right, it is efficient than SVMs and KNNs, right? So this is the reason we are using it. Let's understand again from the prototype only, right? So as after scraping the data and after normalizing the data, we got our data set from the scrap website. Now training the model, for that I've used very most famous scikit-learn model, random forest regression, as you can see. So not going to too much detail how algorithm is working, because that is not our main point right now. Let's say uh, yeah, I also forget to mention that in the data structuring part, normalization part, also here we are structuring and extracting the features from the description also, right? Like as you can see from the description, we cannot know what description this is about. For right now, for simplicity, what I've done is extracted the directly description, like screen size is there, RAM is there, the processor is there, storage is there, the OS operating system is there. So just extracted those features, because from the features we will predict the output, right? So for predicting the output, it is better practice to uh, cut the data into the features, right? So all the betas can be utilized maximum. Let's say here from the scraped data which comes from this URL, we are trying to predict the output for this user query, right? We have done the prediction part here, as you can see, and also done some testing and all the stuff, root mean square error and all the, we have calculated all this, right? Now I want to predict the price for this product. As you can see, this is not directly available in this website, right? What I have done, put some different parameters from different products. So from that we would check if our model is working fine or not. Like here the screen size 12.5, AMD processor is there, Linux operating system is there, 500 GB, right? Like Linux will be coming from here, 12.5 screen size will be coming from here, right? AMD processor will be coming from here, and currently the random state I have put in 42. So let's run and understand the flow. Yes, now you can see the predicted price is 1138, right? So this is how our regression is going to happen, which is random forest regression again, from the given query and from the trained data set from the scrapped website, right? Currently simplicity, there is only one product laptop and there are some limited features, screen size, RAM, storage, because it will be too much complex to explain the process, right? So for that we need to do some the testing things, right? So I have kept the simple things to explain it more properly to you. We are getting the output which is the predicted output. So this price can be used as a benchmarking, right? So this is how the regression part is going to happen. I hope you got the point, right? Now understanding the concept of the algorithm, let's see some already done datasets, already scraped dataset. So this is the Amazon UK Prime price prediction dataset, and there is also a USA price prediction dataset available. Let's go through some UK price first. So as you can see, there is already 481 MB data is available. We can utilize that also for USA also. It is 354 MB data, so it is not small, right? Let's go through some parameters. As you can see in the data set, there is a title, stars, reviews, price, is bestseller, bought in last month, category, right? Let's say for example Eco Dot, which is a product of Amazon itself, which is a speaker, right? There will be category hi-fi speakers, right? The 4.7 star, 15,308 reviews are there. Price of is $21, right? Is bestseller, false. It is not, because here it is bestseller. So these data sets are really helpful to add on the logic, add on the helping to our scrap data, right? Similarly, there is a US data price prediction set, right? Same stars, reviews, price, category, bestseller, bought in last month, right? It is there. Suitcase, Sion soft side, roller luggage is there. So I haven't found for India yet, but there will be a possibility of getting India also, right? Amazon India also, Flipkart India also. There would be some data sets. Here from UK, USA also, we can scrap the data and then do some normalization and some other scrapping. We would utilize this data and add on with our regression models, right? So this is how some data sets will help us to predict our output. I hope you got the point of data sets in this. Okay, so let's move further to time analysis model. Why we require that? Because always vintage factor is always gonna be there, and also we need to forecast the future price trends, right? The thing that is of 100 rupees today might not be at the same price after 5 months or 1 year, right? There will be some change in the prices depending on the markets, depending on the trends, social media, influencer. Lot of things can be present there. Like for example, if any celebrities comes and influences that product, then people are going to buy that and price are gonna be higher, right? So this kind of things can affect the price prediction, so we need to include that in the benchmarking process, right? So let's go through what time series is. So time series is the sequence of data point that occur in the successive order over some period of time, right? So this is what time series is. We are going to forecast the future price trends. For that we are using ARIMA model, autoregressive integrated moving average. This is the model that we are going to use that, and this model uses the time series data and plots it makes the future price trend model, and from that we can know the future price. Let's understand from the code, right? Here for the plotting I have used matplot library, and from stats model I have used ARIMA. Currently just simple, let's uh, simple here I have used just simple uh, linear price trend, which is increasing the day by day, right? From 20,000 to 1 lakh, it has reached today. So I want to know the future price trend graph. So our model, which is ARIMA model, is going to predict the future dates and forecast the time series, and then we are plotting that time series, right? Let's see the predicted output, which is here, right? From 1 1 to 15 4, it has predicted price. So here in the red part you can see the forecasted price, right? This is the normal historical price that we have already given as an input, and the red line which is showing the forecasted prices, right? So there could be possibilities that we, in the scrap data, if the websites are very older and now has been shut down, still we want to utilize that data, then we can forecast the future prices, right? For example, if the data is of 2015 and we want to know from the older historical price what could be the price of that particular thing in 2010 2025. So we have the data of 2010 to 2015, then we are going to use that data and utilize that, right? So this is how time series model are working. Of course here I have shown the linear relation, but it might not be the linear also, right? But for the understanding purpose it is understandable, right? From the linear it is changing the price and predicting the future price. There could be multiple factors, there could be various parameters involved in also, as I have discussed in starting, that if any new influencer comes and starts influencing that product, this price are gonna be changing. This could be another one factor. Also, any, like, no, most of the, what happens, let's from the abstract example understand. Mumbai follows the United States or New York. Delhi follows Mumbai. From Delhi, Lucknow follows Delhi. So there are trends always going there. There is a chain, always a chain. So price are going to affect through the chain, that chain also. So that could be another parameter. So this is how the time series analysis model are going to work. And of course it is going to be benefit, right? Because at the end accuracy matters, and that is what we want to achieve in this case. So I hope you understand the time series models, right? Now let's see data validation and anomaly detection part. So why we do this? Because we need to know that this whole pipeline, after getting the output, how much correctness in the data is there, right? We need to know that, so we can apply that in our predicted output, right? Because if the output that we are getting, if it is not correct, then there is no point of benchmarking that output, right? We need to do some more optimization. So how would we know that there are some anomalies, right? So uh, for detecting anomalies, what we are doing right now is isolation forest algorithm. So we are trying to find out the outliers which the pattern is different from the regular pattern. For example, pattern is linear and there is one outlier which is far away from that linear pattern. Then we have to detect that. So let's see how we are doing that part. So again, the isolation forest we are using from the scikit-learn, and then what we are doing is we are setting some outliers which are uh, acting different from the regular trend, right? And we are marking them in our flag points. So we are plotting it, right? So as you can see, there is a price drop here, price that has been dropped. So you can see the red marks, right? So those are our anomalies. So from that we would know that okay, this is the output but this is anomaly. Then we should do some other thing to do some benchmarking, right? At least we would know that okay, this is not the correct, we cannot apply blindly, we cannot trust this blindly. So this is how anomaly detection is going to happen. As I'm saying again and again, this is just prototype. So you might feel this is easier to find out that oh, that it is not from different regular trend, the trend is different from regular, right? But what if there are thousands of points? Then it is very hard to imagine even that, right? from from even from 4D it gets very difficult to imagine. Then what if there are hundreds of thousands of points and parameters? It gets difficult, right? So our isolation forest helps to find out those kind of anomalies, right? So this is how anomaly detection is going to happen. Finally, after doing this much of processing, we are getting the comprehensive reporting, and in the report we will get the final price estimations and the data source and vintage, all these things, right? So this was just a prototype and the pipeline of the process and the understanding that what we are going to do in this project, how we are going to develop this from the scratch, from the very good and simple UI. Even non-technical person can use that and find the final version, final benchmarking price, that what he or she should do, right? So this is how the process is going to look like after using good frameworks like React Next.js, Flasks, making a good server, tuning this model and putting the best level accuracy at what level we are able to do, and making a public model which is at the production level. This project is gonna look like the insane project that we are going to have in this problem statement, and I'm pretty much sure that it will be going to use by our government, thanks to NTRO organization, which is National Technical Research Organization, to provide us very good problem statement titled Centralized Automated Solution for the Price Estimation and Reasonability, which comes in the smart automation theme. So I hope that our project helps NTRO and I hope that this could be utilized by them, and our hard work, our dedication finds this successful, right? So again, I'm telling this was just a prototype. Fully fledged project will be done as soon as possible, and I'm giving you 100% assurance that it would be very good project. If you have reached to this video this far, I hope you liked the process, the whole pipeline, right? How from the user input to an automated web crawling, normalization, machine learning pipeline, trends, time series, validation, anomaly detection, flagging data points, comprehensive reporting. This whole pipeline, I have tried my level best to explain it very simple from the temporary data set, temporary web scraping websites, simple graph visualizations. So thank you for watching this video. We hope that we get selected in the SIH and we try to implement in the hackathon also. Thank you for watching this video again.